now we get to a limit where up until about a year ago, the only way people knew how to do this was to teach this was pretty hard. And they figured out a different way of approaching it so that actually everybody can do it and it's not so bad. But let's run through the routine. We're trying to evaluate a limit, so we try to plug in first. If I plug in 27 on the top, I'm going to get 27 minus 27, that's 0. If I plug in 27 on the bottom, well, 27 to the 1/3 is 3, 3 minus 3 is 0, so I'm stuck. There's nothing to factor, there's no fractions to fix. It doesn't look like I can multiply by a conjugate. For what it's worth, the real problem is that x to the 1/3 minus 3 has two conjugates, and you need complex numbers to write them out, which is why actually in general people didn't do too much of this. But here's the new way of doing this. You substitute, and you let w be equal to the icky x to the 1/3. Cubing both sides, we get w cubed equals x. I'm going to have to substitute for both. So what happens? Instead of the x, I get w cubed. Minus 27 is minus 27. Instead of x to the 1/3 minus 3, I get w minus 3. Now over here, I have x is getting close to 27, but I don't care what's happening to x. I care what's happening to w, right? So up here, if x is getting close to 27, you can see that w is getting close to 3. So instead of writing x is getting close to 27, I write w is getting close to 3. And I now go through the procedure. I'm going to plug in 3. I get 0 on bottom, I get 0 on top. I write approaching 0, approaching 0. Again, try to avoid writing equals 0 over 0. Once w is 3 is 0, I know that w minus 3 is going to go in on top. I know that w minus 3 is going in on the bottom. To get the top, you can either do long division, or you can remember the difference of 2 cubes formula, which is what I'm using here. The w minus 3's cancel, which is great. Remember, we're looking for the height of a hole in a function. And when I cancel like that, I get the same function with a dot there. And the nice thing is that if there's a dot there, it's going to be continuous, and then I can find the limit just by plugging in. When I plug in, I get 9 plus 9 plus 9, I get equals 27, and we're all done.